Welcome back, students, to another lecture video on metal forming process. So in the previous lecture, we discussed about the recrystallization temperature. So it's a temperature at which new grains are formed. So at the end of the lecture, I said that because of the formation of new grains, its strength improves. So how that happens, we will explore it with the help of this plastic deformation theory. Right. So this plastic deformation theory can be used to explain how material property varies. Yeah. So how the material property varies with the application of stress and strain. So stress and strain. What is stress and strain? First, we will discuss about what are stress and strain. So stress is nothing but it's a resistance offered by the material to deformation. So it's an internal concept. So there are two major forces acting on any material. One is internal force and another one is external force. So whenever you apply internal force, it's a reaction to the external force applied. When you try to bend a material, what happens? It resists the bending force. So that is called as internal force. The inertia, for example, inertia is an internal force. When you are traveling in a bus, for example, so when the brake is applied, what happens? Bus or vehicle, when you travel, when brake is applied, you tend to move forward. Similarly, when a car which is in rest, when it is suddenly accelerated, you tend to move backward. That is because of the inertia. Inertia, what it does is it resists the movement, which is an internal force. Similarly, stress is also an internal force. What stresses does is it prevents the movement. Sorry, it prevents the deformation. So resistance to deformation. So that's the actual definition for stress. The unit of stress is Newton per meter square. And similarly, strain is nothing but it's a ratio of change in length to the actual length. So how much length is changed when you apply load compared to the original dimension. Change in dimension to the original dimension. So that is called as strain. So when you plot a curve for stress against the strain, we can call it as a stress strain curve. So this stress strain curve will give you an understanding of the various deformation process occurring in a material when load is applied. So initially, when the load is applied, what happens is that stress value increases. Similarly, strain value increases. It increases in the form of a linear movement. So with increase in stress, strain also increases up to a certain point, which is called as yield point. So up to that point, what happens is that the material undergoes elastic deformation. So there are two deformation available in a which takes place in a material. One is plastic deformation and another one is elastic deformation. So plastic deformation and elastic deformation are characterized by following example. So elastic, as the name indicates, just like your rubber band. You stretch a rubber band and release it. What happens? It gets back to its original position. Similarly, when you stretch a spring and leave it, it gets to its original position. So that is called as elasticity. It will always regain its shape. When load is applied and released, the material will always regain its shape. So that type of deformation is called as elastic deformation. If you keep on stretching the rubber band 10 times, what happens? It will not get back to its original position, original shape, but it may be elongated. Similarly, when you pull the string by giving excessive load, what happens is that the spring will get deformed. It will not be in its original shape, but it will be elongated. So that type of deformation is called as plastic deformation. So once a plastic deformation occurs, it cannot be reverted to its original shape or size. So that type of deformation is called as plastic deformation. These are the two major deformation happening in a material. So from the stress strain curve up to the yield point, elastic deformation takes place. But what happens in the yield point is that the material will go to a position where it will not be able to reverse back to its original shape. So that type of deformation is called as elastic deformation. So we'll discuss this stress strain theory in detail in the next lecture video. Thank you.